Hello, ladies and gentlemen. Welcome to our second video lesson on probability. This lesson is called the probability line. Please make sure that you have your math notebook and a pen or a pencil, and pause the video at this time if you need to go get those materials, and resume the video when you're ready. All right, ladies and gentlemen, at this time I would like you to draw the number line that you see on this screen. And this number line is representing the probabilities, which we already know are going to be some numerical value between 0 and 1 of any event occurring. So as you can recall from our last instructional video, an event that has a probability of 0 is impossible. It absolutely will not happen. And an event that has a probability of 1 is absolutely certain to happen. It is guaranteed to happen. Okay, we know that there are lots of probabilities in between 0 and 1. On the number line, they show the probability of 1/2, and they have labeled that probability to describe an event that is just as likely as it is unlikely. So basically, it's like that event has a 50-50 chance of happening. Now, anything that is higher than 0 but less than 1/2 is considered unlikely, and that's what you see here. Okay, so anything higher than 0 but less than 1/2 is considered to be unlikely to happen, and anything that is above 1/2 but below 1 is likely to happen. Okay, for this next part of our lesson, I'm going to be referencing our textbook, and this page is from Lesson 1 in Module 4, Topic 1, and it is Activity 1.5. It is located on page M4-19 in your textbook. If you don't have your textbook at home with you, you can always access this online, and your teacher has probably made it available to you already. So in Activity 1.5, we're looking at a simple probability experiment, and the problem says, suppose there are 2 blue, 3 green, and 5 yellow marbles in a bag. They've shown a representation of the marbles in the bag right here. And the first thing they're asking us to do is list the sample space for the experiment. This gives us an opportunity to review what the notation for sample space looks like. And remember, we're going to label that S equals, and then we're going to use our brackets. Okay, inside the brackets, we're going to list all the possible outcomes. So there are 2 blue marbles in the bag, 3 green, and 5 yellow. And then we will end our bracket. Okay, the probability is the number of ways that this event can occur over the number of possible outcomes. So there are 2 blues, so there are 2 ways that we could select a blue marble out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible outcomes. And remember that if we can simplify our probability fraction, we should. So dividing both of these by 2 will give me a probability of 1/5 for selecting a blue marble. All right. The probability of selecting a green, there are 3 green marbles out of 10. That cannot be simplified, so the probability of selecting a green marble is 3/10. And last but not least, the probability of selecting a yellow. There are 5 yellow marbles in the bag out of 10 marbles altogether. And if I simplify that, that will give me 1/2. All right. One of the things we just went over at the beginning of this video is the probability line, and this next statement refers to that. When the probabilities of all the outcomes of an experiment are equal, then the outcomes are called equally likely. Question 3 asks, are the outcomes in the marble experiment equally likely? What do you think? Hopefully you said no. The outcomes are not equally likely because the probabilities for each color marble are different. And in order for them to be equally likely, the probabilities had to be equal. That is not the case for this marble problem. Question number 4 asks us to determine the sum of all of the probabilities. So the probability of selecting a blue was 2 out of 10. The probability for green was 3 out of 10, and yellow was 5 out of 10. If I add these all up to get the sum, I get 10 out of 10, which is 1. Okay, we're going to skip down to question number 6, which asks, do you think the sum of the probabilities for all outcomes of any experiment will always be 1? Explain your reasoning. I'm going to give you just a second to think about that. And hopefully you answered yes. Okay, all of the outcomes together will make up 100% of the possibilities. So the probability of the sum should always equal 1. Okay, ladies and gentlemen, I think you've got enough to get going on today's work. I hope you have good luck, and please contact your teacher if you've got any questions. Have a great day, guys.